Okay, hello everyone. In this video, we'll continue with the Cambridge A-Level Further Maths Component 2, which is Further Pure Maths 2. And this is the variant 1 from the newly released October-November Winter 2025 series. Okay, so we've just done the first question. We'll continue with the second question here, giving us a parametric equation of a curve C. Okay, x is the hyperbolic sine, y is the t plus hyperbolic cosine of t, and we have to find the derivative dy dx in terms of t. Okay, so I think basically we have a x and y in terms of t, so we can probably find dy dx in terms of dy dt and dt dx, or divide by dx dt. Right, as some mathematicians, or rigorously, it's a division. Um, so yeah, we take the derivative of x respect to t. So what is the differentiation of hyperbolic sine? We can refer to your table here, or if you have it memorized, even better. So hyperbolic sine differentiate, you get hyperbolic cosine. Okay, so hyperbolic cosine of t, and dy dt derivative of y respect to t just becomes 1, and hyperbolic cosine becomes hyperbolic sine. Okay. Alright, so now we can do this using the chain rule. Dy dx will be dy dt, okay, 1 plus sine hyperbolic t divided by dx dt. So this actually is a reciprocal, right? So it's a reciprocal of cosine. So yeah, I mean, for the convenience sake of the next question, so I will try and simplify this to become secant hyperbolic t and tangent hyperbolic t. So I'll present my final answer like this to ease the step of the next part of the question, which want us to find the second derivative of this dy dx. So again, we found here dy dx is actually in terms of t, right? So we still have to take the derivative in terms of t. So we again have to use the chain rule. So the second derivative, I'll just write here first. Second derivative dy in terms of dx, it will be, we cannot take the derivative in terms of x because we don't have that parameter here. We only have t, so we only can take the derivative in terms of t, right, of dy dx. And we have to multiply using the chain rule back to get rid of this dt. So as a dt and then dx, because we want the second derivative in terms of dx. So we have the dx there. Okay. Okay, so we have dt. Yeah, we have the dx dt, so we can just take the reciprocal, right? So I mean, from the part A, we have this one, so we don't need to find that again. We just have to take the derivative in terms of t of this dy dx. So yeah, I'll just rewrite this. So it shows clear that we're taking the derivative of dy dx in terms of t, and here I'll just rewrite this also. And again, okay, so I think there's no the hyperbolic secant is not given in the lookup table, so you just treat it as something like cosine power of -1, right? Hyperbolic cosine t power -1. So you take the derivative of this plus hyperbolic tangent of t. So yeah, just treat it as usual. So you multiply it by the power, so -1, and minus 1 to the power, so divide by cosine, hyperbolic cosine squared. And for chain rule, since this is considered as a um, what we call a nested function, so you multiply it by the derivative of this, which is the hyperbolic sine. Okay, and yeah, hyperbolic tangent I think is given in the lookup table, so the secant squared, hyperbolic secant squared. So this one, and we want to prove it in this particular form here. So this secant square, I'll rewrite it as 1 over cosine square, right? And we can combine both of these fraction together. So it becomes 1 minus sine hyperbolic over hyperbolic cosine squared. Okay, so this is where we're combining these both fractions together. And okay, we're not done yet. This is just the derivative of dy dx in terms of t. So to finally find the second derivative d squared by dx squared, so we take this 1 minus sine hyperbolic t over hyperbolic cosine squared of t and multiplied by the reciprocal of dx dt. So 1 over cosine hyperbolic t. And yeah, this one will be quite straightforward because it's just a multiplication, right? So this two hyperbolic cosine on the bottom becomes a hyperbolic cosine cube. And just like that, we've shown exactly in the same form as the question wants us to give. So we write shown. Okay. Oh, part C some more. We want to find the Maclaurin series of y in terms of x and until the term x squared, right? So usually, even in the real world, I think you're going to, at most, you're going to do up to x squared also. So we don't need that much accuracy for most purposes. And yeah, so we have y, we have x. So let's look at the Maclaurin series formula here. So I'll just rewrite what's here first. So y of x, we can restate it as y of 0 multiplied by, add with x multiplied by y prime of 0 and x squared over 2 factorial multiplied by the y double prime of 0 and so on and so forth, right? But you have to be careful here. So common mistake is this 0, okay, this 0, this is x equals 0. Again, this is all x equals 0, right? But what you're given in your or what you have done here, the dy dx, the y prime and y double prime is in terms of t. So sometimes the x and t, they do not, or you should assume that they are not the same value at first. Okay, so when x equals 0, we need to find what's the value of t so that we can substitute accordingly, right? So when x equals to 0, how to find the value of t? We have this equation given to us. So t will be the hyperbolic inverse sine of 0. Yeah, so we know from your fundamental that hyperbolic sine, maybe I can write here, hyperbolic sine is the same as this one, e negative x minus e positive x minus e negative x divided by 2, right? Something like that. I think it's one is positive, one is negative, and divide by 2. So we know that when x is 0, hyperbolic sine x is 0, so the inverse is also true. So hyperbolic sine 0 is 0. Okay, and so from this we can try and substitute back into our y and dy dx and the second derivative to get these coefficients. So yeah, y when t is 0, what is the function we have given to us in the question, right? So 0 plus hyperbolic cosine of 0. 0 plus hyperbolic cosine 0. So again, hyperbolic cosine, let's try and recall. Hyperbolic cosine, there will be ex plus, right? One hyperbolic sine is minus, then hyperbolic cosine is plus. So e0 is 1, e negative 0 is also 1. So 2 divided by 2, that is 1. So y of 0, that is 1. And so dy dx, when t equals to 0, also let's try and find the next coefficient. So secant of 0 and tangent hyperbolic of 0. Okay, so hyperbolic secant 0, tangent hyperbolic 0. Okay, so the reciprocal of just now what we found is this one will be 1 lah, basically, because this will be 1 over the hyperbolic sine, which will be 1. So 1. Hyperbolic tangent, so we know it's a hyperbolic sine divided by hyperbolic cosine, and since hyperbolic sine will give us 0, it will be 0. So it's just 1. Last one, the hyperbolic, the second derivative, evaluate at t is 0. So 1 minus sine hyperbolic 0 divide hyperbolic cosine cube of 0. So this top hyperbolic sign that gives us a 0. So 1 divided by hyperbolic cosine 0, that is 1 power or cube it, there's still 1, so just 1. And yeah, finally we can just substitute all the coefficient. So y of x, you can get just now y of 0 is 1, y prime of 0 is x, I mean just 1x, and double y prime 0, that is 1. So we have x squared over 2. And there are other terms but we just don't need to express it. Okay, so that is part C for this question 2. I think, yeah, we'll do the rest of the questions soon, so stay tuned and thanks for watching.